In this video, we are going to discuss and demonstrate the new Geomagic X Go product from Oqton. Okay, so what we'd like to accomplish in this demo is go over what is the new Design X Go product, who is it for, basically what is the target audience for this product. We'll review the complete Design X lineup because there are some changes to it. And then we're going to do a quick overview demo of the new Design X Go product so you can see what functionality and capabilities are in that product. Let's start by talking about what is Design X in general, because Design X has been out on the market for many, many years. It is the leading reverse engineering software on the market, but traditionally it's only been a very high-end product, and now we have some new modules that are available in the Design X Go, Plus, and Pro, and we'll get more into that in a minute. But let's talk about what is Design X. So Design X is a 3D scan to 3D CAD software product, and what it does is it bridges the gap between CAD systems and scan data, because most CAD systems do not work well with 3D scan data. A lot of people don't understand you cannot import 3D scan data into a CAD system and do much with it. The other misconception is there is no push button to get from scan data to CAD data. Okay, it is a process, and we're going to show that today. Now, there are many free products out on the market that do mesh cleanup and do some basic stuff, but to go to a CAD model, especially a more complicated CAD model, they just don't work very well. Okay, and the other thing with Design X is you can output neutral CAD files like STEP, Parasolid, IGES, but then it also has a direct interface to many CAD systems, and we're going to demonstrate that later and show you the value of that. So who is Design X Go for? Well, for a lot of people, it's going to be those who have purchased their first 3D scanner. Maybe they've bought kind of a mid-price scanner. They've never done this type of work before. They're just getting into 3D scanning and reverse engineering, and they want to get some good software to get started. So it comes in at a great price point. You can also upgrade to the Plus or Pro version down the road if you want to. And the typical parts are going to be kind of mechanical driven parts, CNC machine parts, basic cast parts, basically things that are sketch or dimensionally driven. What it's not going to be good for is very organic, very free-flowing parts. Things more like automotive bodies or boat molds and hulls, things that are very, very organic and have very complex surfacing. It's probably not the best product. That's where the Plus or Pro are going to be a better fit. But they basically need to build CAD data from scan data. Maybe they've tried some of the free stuff. Maybe you've tried to work with your CAD system and it's just not working. This is going to come in at a great price point and ease of use to get you started to go from scan data to CAD data. So as I mentioned, the three different modules now, you have Design X Go, which is really a great place to start. And if at some point you want to upgrade, you can move up to Plus. Now, Plus used to be called Design X Essentials, and we do have a good video on that product. I'll put a link in the description below. Nothing has really changed with that product. It does now have the live transfer, which it didn't have, and you're going to see that when we get into the demo. And then, of course, the Pro version has been around for really the beginning of the product, and that literally has everything in it. It is the most powerful version of the Design X products. Now, you can go online and download a comparison chart, and it's actually quite longer than what you see here. And it lists all the different types of operations and which version supports what. And that is helpful. But what we're going to do here in a minute is we're going to do a demo and actually walk you through the interface and just show you what is in the product and kind of show you what you can do with it. I think that's just an easier way for people to understand, because you may not even understand what some of these commands mean or do. So hopefully we'll be able to show you exactly what the product can do. And we've also got some comparisons of Design X Essentials and Pro that you can go watch. I'll also link those in the description below. And again, Essentials is now called Design X Plus. So just a basic overview of Design X Go is it's available in subscription or purchase. I'll put some information about pricing in the description below, because that can change. So I'll just add that to the description. There is no network version of Design X Go. There is for Plus and Pro, but typically people starting out with Design X Go do not need the network version, and it's an additional cost. There's also some free training videos online you can go watch that are pretty helpful. And of course, EMS can provide training for you either via the web at one of our offices, or we can come to you and do training. But most of it with this product can be done virtually, whether it's videos or a virtual training session with EMS. So if you want to discuss a demo, if you'd like to maybe do a free trial, if you have some specific questions, or maybe you're just ready to purchase the product or purchase some training, regardless of where you bought the product, you can get in touch with us at 877-845-2700, or you can send us an email at info@ems3d.com. So next, we're actually going to bring the software up and do a demo, and we're just going to use this simple casting bracket you see here, but we're going to show importing the scan data. We're going to create some of the CAD, and then we're going to show you a live transfer to Solidworks and just show you the workflow a little bit. We're not going to go into a ton of detail on this. We also have other videos, like I mentioned, on Design X Essentials and Design X that go into a lot more detail, but this will show you the capabilities. We'll walk through the interface a little bit and just show you what you can do with the Design X Go product. All right, so let's start by taking a look at the interface of Design X Go. Now, this is going to look like all the Design X products. It's just going to be a subset of the higher end products, the Pro and the Plus. And also, I'll put a link in the description below to some of our other Design X demos on both what used to be called Design X Essentials and then the full-blown version, which is now called Pro. So if you want to look at those. But I'm just going to really quick walk through the interface just so you understand it if you haven't seen it before. But it's very typical of what a CAD system looks like these days. It runs on the Parasolid modeling kernel, which is the same as SolidWorks and Siemens NX and Solid Edge, Autodesk Inventor. So a lot of the commands and the way you do things will be very similar. But you've got tabs across the top here. You can pick that bring the ribbons out for different things. You'll spend a lot of time in a couple of them. But the home page has kind of some of the things you do all the time. So you've got these across the top. Here you've got your modeling tree here. So as we build entities, you'll see them show up in the tree. Down here is just all your different entity types. This is going to allow you to turn them on and off as you go. And over here on the right, you've got a properties tab that as you pick different things, you'll see them. There's a display tab for things you want to show or not show. And then the accuracy analyzer, which will show. And then down at the bottom, these are just same as over here where you can turn things on and off. These are your different entities. These are some of your different selection tools. So in a nutshell, that's what it is. Some of this will make more sense once we get going here in the demo. All right, so let's go ahead and get started by importing some 3D scan data. So we're going to come over to our import menu. And if you look at all the supported file formats, you can see here what we have. So we've got a lot of different point cloud and polygon mesh formats. The most common are STL and OBJ for polygon mesh. And then there's all types of point cloud formats like PTS, PTX. There's even some direct formats for different 3D scanners. Okay. So the good news is there's a ton of different formats to get your scan data into the system. Okay, so we're going to load an STL file. So I'm going to click, which is probably the most common. I'm going to say import. Now, STL files do not have any units in the scan data. It doesn't tell you, like a CAD file, that it's millimeters or meters or inches or whatever. So it's just going to try to guess. So you can see here it thinks, well, if it's inches, the part would be 230 inches long. Well, I know it's not. It's a small bracket. So I'm going to set it to millimeters, and that looks right. So the part was scanned in millimeters. I've set my units to inches. You can set it to whatever you want, and we'll hit OK. Okay. So the data comes in. Let me turn off the planes for a minute. Let's take a look. So typical scan data, you can see there's some areas missing. We've got some holes. We've got a little bit of scatter data hanging out there, etc. Because, this is very typical. Depending on the part, not all of it can be 3D scanned, so data is going to be missing, or just the operator missed it. But for the way we're going to model, it's not the end of the world. We don't even care that that data is missing, okay? Now, let's also talk about what is scan data, okay? Because the misconception many times is scan data is CAD data. So you look at this and say, hey, that looks great. Well, scan data typically cannot be imported into a CAD system and used in any way. It is not a CAD file. It is not ready for manufacturing, okay? It is just a bunch of polygons or points, okay? So if I zoom in and look around, you can see what this is. It's just polys, okay? There's no intelligence here. This is not a plane. This is not a cylinder, et cetera, et cetera. So that's the whole point of Design X, and in this case, Design X Go, is we need to build CAD. Now, the first step in building CAD is we want to put this in a good coordinate system. So if I go to a top view, if I go to a side view or a rear view, you can see it's not in a coordinate system, and you really don't want to model with it in this, okay? So when you typically the scanners, unless you predefine a coordinate system, it's just a random coordinate system. So the first thing we're going to want to do is set up a coordinate system, okay? Now, we're going to go under our alignment tab, and first thing we're going to do actually is build some geometry. So let me go back to the home, because I want to have some reference geometry. Now, when I look at a part like this, I'm typically looking for planes, cylinders, maybe a point to set up an alignment system, okay? So if I look at this part, probably the two easiest, best things to use is this, what looks like a plane here, and this face here. So I'm going to use a selection tool called Smart Selection. These are all our different ways of selecting. And this is a great tool because what I do is I click and I can move the cursor up and down, and it's looking for similar curvature in an area. So that's pretty good there. So that all fits a plane pretty well. Then I'm going to go under the plane command, and I'm going to say fit a plane through that data. Okay, so let's turn our planes back on. Let's turn the front, top, and right off for a minute. Okay, and you can see what it's done. It's averaged a plane through that data. Okay, I'm going to do the same thing on this plane here, and then create a plane. And now we have those two planes, okay, like you see here. Now I'm going to go into the alignment tab. I'm going to do an interactive alignment. And I'm going to do a 3, 2, 1. You can also do an XYZ. We're not going to get into a ton of detail in all of this, but let's pick our first plane. That's going to establish the X and Y, and then the vector that way, okay? And then we can flip these over if we want, if we want them going a certain way. You can also set a position, so if you wanted it in a certain spot, you could do that as well. I don't really care for this. That's good enough. So now let's turn off plane 1 and 2 and turn back on the top, front, and right. And when I go to now some true views, you can see it's lined up. So that's always the first step, is setting up your coordinate system so that you can start your modeling. All right, so the next step is kind of determining how we want to model this. So before you just start randomly modeling, you always want to try to figure out, well, what's the best way to do it? And I always try to look at what's the major feature of this part. And to me, the most major feature is this outline here. This is like the main body here. We need to model that. And then, of course, we need to model this shape and so forth. So that's the way I always look. So let's turn on our planes. And then Let's move over to the model menu. So this is going to be one of the menus you're going to spend a lot of time in is model and sketch. Model is where you build your models, okay? You build your solids or your surfaces, okay? Just like in most of your CAD systems. But the first thing we'll do is sketch, okay? Because you got to build a sketch before you can then build a solid body. And there's two forms of sketch. There's regular sketch and mesh sketch. Regular sketch is basically pick sketch, you pick a plane, and you just start drawing something in 2D. It's not related to the scan data necessarily at all. Mesh sketch is driven from the mesh, okay? And this is the one you're going to use a lot. So I'm going to pick a plane. Now you can see our plane's right up here at the top, but I don't really care where it is. You'll see here in a minute. So the first thing I need to do is pick a plane. I'm going to pick this plane. Now it's going to cut what we call a reference sketch right at that plane. But many times what you're going to want to do is you're going to want to move that reference up or down, right? So the sketch will end up being at that plane right up here. Okay, that's where it'll be located. But you can sample the mesh data anywhere you want, right? But the problem is, if you look here, I cannot pick an area on this because of the curvature that gives me that whole shape. Okay, so I'm going to set this back to 0. Okay, that's right on our plane. And then over here, we've got another little arrow we can drag up, and this is called silhouette. Okay, so what I'm going to do, let me get in the side here. So I'm going to drag that one up until kind of the whole thing is encompassed. And this is almost like if you're familiar with like a parting line in a mold, it just looks at the farthest out point on the scan data, okay, in this area that I've picked, okay? So you can see what it's done. So I'm going to hit OK, okay? So now it's up on that plane, but again, I don't care where it is, okay? So now I have this profile. Let's turn off our mesh. This is called a mesh sketch, okay? Now the misconception is this is CAD. This is 2D sketches, but it's really not. It's just a reference. Now we're going to build our sketches just like you would in CAD, okay? And that's lines and points and so forth. So you can see you've got quite a few of the commands in here to do that. You don't have all of them that Plus and Pro have, but you certainly have enough of them to do a lot, if not, maybe all of your modeling, okay? And there's a couple approaches I can take to this, okay? So I can just sketch the whole thing, or I can assume that this part is a mirror image of itself and set it up that way. So how I'm going to do that, I'm going to assume this circle is centered. Okay, I'm going to pick this, and I'm just going to window in. Let me do that again. And I'm going to set my selection tool to be the box. I'm going to window in, and that is going to fit a circle through there. Okay, so let's take a look at this. Now you're going to look right away, and you can see, well, this is a representation of the scan data. Let's go back and turn that mesh back on. Okay, so you can see we've got some rough areas. We've got some missing data. Okay, so that what the software is trying to do is fit a perfect circle through imperfect geometry. Okay, and that's a common theme with scanning. You're scanning a manufactured part that is not perfect, and you're trying to go back to the design intent, which, everything indicates this should be a circle. And I can actually look at the deviation here with this accuracy analyzer I mentioned, and I can scale up the deviation. So you see, this makes it easier for me to see. And if I highlight my cursor over, I can see how much it deviates, okay, all the way around. And this is very typical, especially a cast part that hasn't been machined, okay? So if I do want to look at it, I can do that. Okay. But anyways, the reason I've established this circle is now I'm going to draw a line through the center, and I'm going to make that line horizontal. You see how it gives us those constraints. And this geometry I'm going to create as construction because I want it as reference, but I'm not going to use it in my sketch. So now I'm going to start doing my sketch, okay? So you're going to want to fit lines, arcs, splines, fillets, etc. So where do we start? Well, let's start over here. And I'm going to do what's called a center point arc. And you see when I pick this segment, okay, it's going to fit an arc through it. Okay, that looks pretty good. And then let's do a line. I'll pick this one here and fit. And again, we can turn on that accuracy analyzer and we can look at it. And again, nothing is perfectly flat, nothing is a perfect. So you're always looking at, well, is it close enough? Is it the design intent? Now, what are we going to do here? We've got another circle, kind of maybe a flat and another circle here. A couple ways we could do this. One is a tangent arc where we pick here and we try to fit a tangent arc. And again, this gets into design intent. Should this be tangent? Well, let's go ahead and drop this in, even though it doesn't fit right. And, I could come in here and pull this around and tug on this, and do different things to get it to fit or be close. Okay, that's one option. I could then come in here and say fill it between here and here. And as you see, I can kind of fit, right? And the idea here is by making tangencies, everything is nice and smooth, okay? And then the last thing we need is our circle here. A couple of ways we could do that. I could fit a circle, and then I could come in and grab this and try to make it tangent by double clicking and say make that tangent, okay? So you've got lots of ways to do this to get, what you want, okay? And then now I'm going to do a little bit of trimming. So let's go ahead and trim this up. I'm going to use power trim. I'm going to get rid of that piece. This piece, oops, wrong way. This piece here. Oh, let's do this. I don't have another piece there. So let's just draw this over to here. And now we'll trim it, okay? So it's looking for the next intersection. Okay. And we can just get rid of that now. Okay. So there's half of our sketch or half of our profile, okay? And what we've done is we've made everything nice and tangent and smooth. Does it match the scan data perfectly? No. And if you wanted to match it perfectly, you could, but that's usually not what you want to do. You want to make things the way it was probably designed, okay? So we've got everything there. We've done half of it. Now we'll come in here and we will mirror it over. Our symmetry line is what we established here. And then let me set my box select, and then we're going to pick these entities here, and we've mirrored it over, okay? So there's our first profile. And you can see it doesn't match over here perfectly, but again, design intent probably tells me that, this is the way it should be. Okay, so now we can exit out. So what have we just done? Okay, we have built our first sketch. Let's turn our mesh back on. Okay, so just to reiterate, a mesh sketch is not a real mesh or not a real sketch. It's just a cut through the scan data, and it kind of represents what a sketch would look like. But you still have to go through and fit lines, arcs, circles, tangents, ellipses, splines, etc. And that's the key thing that people don't understand. There's no push button to build this geometry. Now, in the higher end versions, Plus and Pro, they do have an auto sketch. For simple geometry, it works. For complex geometry, it doesn't. One more thing. Let's go back in the sketch. So at any time I can go back in. I didn't point this out, is you can add dimensions and then drive things off dimensions. So for example, if I did want to dimension this fillet, and I did see how it's 25.699, I could make it 26. Okay, I'm going to undo that. But if you want to dimensionally drive it, you can. Okay, so if there are specific dimensions that you want, you can do that. Okay. So let's discard that. Okay. So now we have our first sketch. Let's go back to our mesh. Okay. Now that sketch is up on that plane we established. The next thing we're going to want to do is turn it into now a solid body. And we'll go under Model. We'll hit Extrude. We're going to pick that sketch. Now, do I want to go up? I don't really need to go up because I'm at that plane. Okay. I do need to go down. So let's drag it down. But you can see because this has curvature to it, when we do a blind extrusion, and your extrusions are all the common ones, blind, up to a surface, up to a region, I'll explain region in a minute, up to a body or mid plane. We're just doing a blind. We're just going to go down some value, okay? Because we can't extrude it to a curve, okay? Now we're going to do that essentially in a second. Now let's go ahead and hide that for a minute. So we've got that established. Now, the next thing I want to show is how do we do more of a curved surface like we have here. Now, this is probably a radius here, and I could fit a cylinder through it, but I want to pretend it's not because I want to show a different command. And this is something we use quite a bit. So we have this curve shape. Now we do have primitives, so we could loft through here a cone, a cylinder, a torus, a torus, etc. But I don't want to do that. I want to fit a surface through here. And there's a really neat command called mesh fit. So I'm going to come under here again. I'm going to use that command. I'm going to pick. You see I'm grabbing all of this area here. And if I want, I could also add and pick this here. Okay, I want to avoid some of this stuff that, but you can see it's generally got picked up that shape. Now, I'm going to create what's called a region. So let's go to regions. You don't necessarily have to create this region, but it is handy because from now on, this region will be here if I ever need it. So I'm going to click insert. Okay, so you can merge them, you can split them, or create one. Okay, what that does is that color codes the geometry. Okay, it doesn't change anything. It just now color codes it. And if you highlight over, it says, hey, this looks like a cylinder. Okay, so if I did want to create a cylinder, I could come right under here, pick this, and fit a cylinder. Okay, so not only does it highlight it, but then it tries to, let's create one more. Okay, so let's come over here and just make one here. I'm going to pick that. I'm going to go to region, and I'm going to insert. And if I highlight over it, it says cylinder. So it thinks that's a cylinder too, probably because there's a little bit of curvature to it, but it could say plane, right? So now we have this color-coded, so now we have this color-coded area, and I'm going to now do a mesh fit. What is a mesh fit? A mesh fit, it's like, I call it a shrink wrap. So I'm going to pick this surface, okay? I'm going to go to the next step. Now you can control, I'm not going to get too crazy in this, but you can control deviation or control points. I'll just do control points, how smooth I want it. Do I want to extend it? Let's just go to the next step. You'll see, okay? So it's going to fit a surface to fit. And this is great when you have some just very organic shape surface. It's going to fit a surface, okay? And you can add additional UV lines in here. So if maybe there was a little bit more curvature in here, there's a ton of control. We could spend quite a bit of time on this. I'm not going to, but basically what it's going to do is fit a surface through that area that I selected, okay, through that region or just that selection group. And if I do a deviation analysis, you can see here, yeah, it's all green, which is in my tolerance of, in this case, 0.1 millimeters. And you can see here, that looks pretty good, okay? So let's go back to our solid body. And if you've used a CAD system before, you probably know what I'm about to do. Now, I'm going to chop off this main feature by using the cut command. So we have cut and Boolean. I'm going to use cut. The tool entity will be that surface. The target will be that. And we are keeping, let's turn our mesh on just to double check. We are keeping the top, okay? So there we go. So we've got really our first major feature. Let's turn our mesh back on. Okay. Now we can also do that deviation analysis on the body. Now a lot of it is going to be wrong because we still have more work to do, but we're certainly good up here on the top. We're certainly good here on the bottom. Any gray areas or areas that are way out, obviously, or we haven't done anything with. We're pretty good on the sides. There may be a little bit of draft to this part. We're going to design it without draft. Okay. So that's the first step, okay? So we're building feature-driven solid models here, okay? Now, if we turn off our body, you can see we've got this area here we're going to need to cut out. We're going to need to model this, and so on. Now, I'm not going to go into fully modeling all this stuff because the Design X videos will show you. I'm really just trying to show the concept here and keep this video short. Let's just do one more just to keep things moving along. So let's go ahead and design this feature here, okay? So we know if we turn back on our planes, we've established a plane already here, okay? So same thing. I'm going to come in here and I'm going to say sketch. I'm going to pick this sketch here. Oops, sorry, mesh sketch. Pick that sketch. Now this one I can just do the standard sample. I'll come up right here in the middle. I'm going to pick that sketch. I'm going to rotate it around because I just like to look at it like this. Let's hide our solid body. Let's hide our mesh, okay? So here's the main shape I'm after. Same thing, we could set up a symmetry line if we want, just to keep things moving along. I'm going to pick some of this, and fit a circle. And then we can fit a line. And I'm just going to go down into the part some arbitrary distance. Okay. And again, we're going to pick, and I'm going to keep everything straight. Okay. You can also, I missed, so if I right click and say make that vertical, you can see what that's going to do. And then let's corner trim this up because we want to close this. Anytime you're going to extrude a solid body, it has to be closed. Okay. And then we're done. Oops, nope, we got to go back. So again, you can always double click. We need to trim. And we'll do that power trim and get rid of that piece there. Okay. So now we have the next feature. Okay. Let's bring back our mesh. Now, how do we extrude this to the other side and get it exact? Well, let's look at a couple ways. I'm going to hit extrude. We can do blind extrude. And if I just come into a side view, I could kind of eyeball it. It'll kind of snap to the geometry, okay? And I could say, hey, let's make it 17 in this case. Again, we're not doing the draft. We could, but just, again, keeping this simple. Okay, that's one way to do it. I could establish a plane. Let's say I don't want it to, I want it to be exact. Let me show you another neat way to make a plane. I can come in here and say plane. I can pick a position, just pick anywhere on there. I can pick a normal, which will be that plane there, okay, so that they're parallel. And so now I've built that plane. So now when I do my extrude, this time I'm going to go up to a surface, and that'll be that plane. And then now we've got it. Now, when I extrude it, let's double click our extrude, I can cut it or I can merge. In this case, we want to merge so that it's all part of the same body, okay? So you can see what we're doing, and then we've got to chop away and do the rest. So this just kind of shows the basic concept. So let's walk through. You've got extrude, revolve, loft, sweep. You've got those primitives, like I mentioned. You've got then the same thing for surfaces, okay? Because not everything might be a solid. You might be doing a sheet metal part, okay, where you just build one side and offset it. You've got the same commands. You've got the mesh fit that I mentioned. And then you can cut, boolean, fillet, chamfer, flip normals. This is all of your modeling tools right here. Your surfacing tools are limited to auto surface, which is just a patch network. It's great for organic stuff where you just need a quick wrap around the part. If you're doing more advanced surfacing, like a car body, like a boat, a boat hull, something very organic, you're not going to be able to do much with this product, okay? You could cut some sections through a part and then take those into a system, a CAD system and do lofting and stuff, but it wouldn't be ideal, okay? But this is just showing you the basics of it. There's also 3D sketches that allows you to do kind of more of that 3D organic stuff. But you're primarily going to be using either just sketches or mesh sketches, okay? And then you're going to do, basically all this modeling, okay? So that's the main thing. Going over to polygons real quick, if you did want to clean up the scan data before you model it, we really didn't need to. But you have basic remesh, which just tries to clean it up and close it all up. You can decimate, which is dumb it down. You can do some basic smoothing. You can split the scan data into multiple pieces. You can offset it. You can fill holes. You can merge and combine if you have point cloud data, etc. So you do have some basic tools. But I find, we don't care that there's holes in this data because we're fitting sketches and just fixing it as we go, okay? Okay, so here is our finished part. So if you look at it here, this is the complete part. Let's turn on the mesh, okay? And now we can do that accuracy analyzer and look at the whole thing, okay? So, some of this stuff, some of these fillets, some of these areas, we really don't care. We want it to look nice. Since it's a cast part and it doesn't really matter, we're not going to be too worried about that. Same with you see up here, the part is just, it's a rough cast part. So we want to make it into a nice CAD model because maybe we're going to CNC machine this, so we want everything. We might cast it again, but we always want to start with, what the design intent is, okay? So now we have our CAD file, okay? So here's our scan data, which is just points and polygons. It's not real CAD, okay? If you turn on the mesh, you can look at it. It's just a bunch of little triangles. Okay, you cannot take this into a manufacturing system and do anything with it. What we ended up building was a CAD file. This is now surfaces, including sweeps and fillets and planes, etc. This is our final CAD model. Now our export options, if we pick it, are the following: STEP or IGES, which are the two most common neutral file formats available. So we can now save this out. Most people use STEP, okay? And then anybody can import it into their CAD system. Now the only downside to that is they don't have this history tree over here, okay? This does not go with it. So all the work we did here, it's not to say that it's lost, but it's whoever's using it wouldn't be able to go back and modify, let's say, this sketch, for example, okay? So, and for most people, that works just fine. Other people want to take this into their CAD system and maybe continue to edit it or make changes to it. And that's where this live transfer comes in. So the live transfer is available for Solidworks, Creo, Inventor, Siemens NX, and AutoCAD, okay? What is that going to do? That's going to roll back the tree and rebuild everything in the host CAD system. So let's show how that works. Okay, so you just tell the software you're doing a live transfer. In this case, we're using Solidworks. And what it's going to do is it's going to open up Solidworks like you see here. And then it's going to start building. You see the history tree on the left starts to populate. So everything we did in Design X Go is being basically redone. So think of it as like the recipe. So it rolls back that history tree and it literally rebuilds every plane, every sketch, every feature that we created in Design X Go. It is rebuilding it in Solidworks. So again, the advantage of this is when this is done, it will look like somebody designed this product in Solidworks. Meaning you can go back to any plane, you can go open up the sketch on the plane, you can go make changes to that sketch and then roll back forward. And, unless you break something, if you're familiar with CAD, you'll know what I mean. It will make those changes and roll back through the tree. Okay, so now not everything goes through automatic because Design X Go does do some things a little bit different than SolidWorks because it has the scan data as reference to do certain things. So I don't want to get too technical, but if you know how this live transfer works, you can minimize that, okay? But what happens is it will stop and it'll ask you to do something like maybe cutting a surface. SolidWorks might require to know the normal direction or which side to keep. And that may not come over in the live transfer, so you just have to basically make that selection and then hit continue. But the beauty of this, at the end of the day, instead of having a neutral file like a STEP or an IGES file that does not have a history tree, it's what we call a dumb solid. This is an intelligent solid. This will look like it was designed in SolidWorks. So that's the big difference between the live transfer and just a neutral file. So not everybody needs the native file, but if you do, that is now part of Design X Go. It is now also in Plus, which used to not have it. And then, of course, it's in the Pro version. So that's how it works in Design X Go. So you can see once it's done, it looks just like the model we had created in Design X Go, but now it is in SolidWorks with that complete history tree, which allows you to do further editing. So this wraps up our demo on Design X Go. As I mentioned earlier, if you want to learn more, set up a web demo, a free trial, maybe ask some questions, or maybe you're ready to purchase the product and get some training, give us a call at 877-845-2700 or send us an email at info@ems3d.com.